everyone, welcome back to another week of STEMpower. Today, we will be learning about sound
with May and Shelli. I will be teaching you about sound in the first activity, and Shelli will be introducing the rest.
The fun fact of the day is that the speed of sound is 767 miles per hour. When an object goes above that speed, it is known as breaking the sound barrier, and it causes a large shock wave or a sonic boom. You will have two activities, sound and string and the sound of music. In the first activity, you will learn about how sound travels through waves through a medium by observing sound through different objects.
Before we start, let's learn a little bit about sound and how sound works. Sound travels in what is called a sound wave. Sound waves don't go up and down like you think. They're actually more like if you push one end of a slinky, the sound moves like this horizontally through the air, or medium, whichever thing it's traveling through. This kind of wave is called a longitudinal wave. When there's a vibration, it causes other particles in the medium, which are things like air or water where sound travels through. It causes particles in the air that I'm speaking into to vibrate, and then they keep vibrating until they hit an obstacle or somebody's ears. We can hear different types of sound because there's a different volume and a different pitch. Volume is like when I shout, ah, or if I whisper, like this. Volume is measured from the middle of the wave up to the highest point. You can see here that I've shown it on a diagram, and this is actually called the amplitude. The higher the amplitude means that there's a higher volume. A higher volume basically means that it's just a louder sound. Also, if I have a high volume wave, which results in a higher amplitude, that also means that that sound wave has higher energy. Pitch is measured by how high or low the sound is. So for example, a high pitch, ah, would be like that, and it would be measured by a short distance between the crest of each wave, or a short wavelength. You can see here that a wavelength is measured from crest to crest or trough to trough, which basically means the highest points or between the lowest points. So a short wavelength is a high sound, ah, and a long wavelength is a lower sound, like ah. One way that we can visualize this concept is with a guitar. You can see here that the thickest string is here and the thinnest string is here. When you pluck the thickest string, it is hard for the string to vibrate, so the vibration will move more slowly. Slower vibrations mean that the frequency of the note or the sound is lower, which causes a lower sound. You can see in this diagram that this pitch has a long wavelength and a low frequency. If I pluck the thinnest string, it is so easy for the string to move that it can vibrate very fast, which means that the sound has a high frequency, a short wavelength, which means it will be a higher pitched sound.
In this activity, you will need pencils, a long piece of string or yarn, 2 metal spoons of different sizes, 1 tablespoon and 1 teaspoon, and printed handouts, 1 per group. First, break into groups of 2. Before you begin, take 1 to 2 minutes to make a hypothesis about which spoon will make a louder sound and why. Tie the yarn to the middle of the spoon by knotting it below the head of the spoon and leaving approximately the same amount of yarn on either side. Take the long ends of the yarn and hold them up to your ears. Leave a little section of yarn on either end for the next step. Take a bunch of that section of loose yarn and put the bunches safely into your ears to block out other sounds. Make sure you aren't putting the yarn too far into your ears. Ask your partner to tap on the spoon with a pencil. Have the student who's holding the string to their ears record their observation on the handout provided.
It is important that you don't touch the spoon with your hand. The only thing that should be touching the spoon is the string, and it should be dangling in air.
Repeat the same steps with the other spoon. Then, repeat the same experiment with the longer and shorter length of string. Take 1 to 2 minutes to hypothesize how the length will influence the sound and why. Change the length of string by bunching up more or less yarn. Then, have the partners swap roles and repeat the same steps.
When you switch, use new string.
After the activity, summarize what you've learned in the final box on the handout. The first discussion question is, would a plastic or metal spoon create larger vibrations or louder sound? Make a guess and explain why. A metal spoon would make a larger vibration than a plastic spoon. This difference in vibrations can be explained by how sound travels. Sounds travel by bouncing off of the particles in the substance. Metal is denser than plastic because it has more particles and is heavier than a plastic spoon of the same size. Because metal has more particles for vibrations to bounce off of, the vibrations are able to move faster than they could in a plastic spoon. Since the sound dies out as it moves, the faster the sound moves, the more sound remains to be heard. This means that the metal would have to be louder than the plastic. The second discussion question is, how does sound travel on the string? Sound requires a medium, or something to travel through. Think of a person traveling from one country to another. There must be some way for them to be transported, such as a car, boat, plane, or more. Sound functions in the same way as physical transportation. Just as people prefer plane travel because they are able to arrive at their destination more quickly, sound prefers to travel through solids because that medium allows the sound to travel faster than through liquid or air. The sound travels through the yarn, the medium, from the spoon to the ear. Second activity, the sound of music, you will make your own sound by turning household items into musical instruments. You will observe how the different instruments create different tones and vibrations. In this activity, there will be 3 stations. The first station is music with water, and you will need 10 drinking glasses, access to tap water, and a few pencils. In the second station, pan flutes, you will need a large number of straws, enough for each student to have 8, scissors, tape, rulers, and markers for the table. The third station is guitars or banjos. This station will need lids or small plates, 1 for each student, an assortment of rubber bands, duct tape, large popsicle sticks, and markers. You'll be divided into 3 groups, 1 for each station. For the first station, music with water, take 5 drinking glasses and line them up, filling each glass with a different amount of water. Add more and more water to each glass as they move from left to right, so that the first glass has very little water and the last one is almost full. Tap each glass with a pencil and compare how they sound. Discuss the differences in sound. In the second station, pan flutes, you will take 8 straws and share the rest of the materials from the table. Mark the first straw at 10 inches with a marker, the next straw at 9 inches, and decrease the size by 1 inch until you mark all of the straws. Cut out each of the marks so that each straw is a different size. Line up the straws side by side with the longest straw on the left and the shortest straw on the right. With all the straws lined up, take the straws together horizontally. The tape should wrap around the front and the back of the straws. In the third station, banjos, take each of the 4 rubber bands and stretch them onto the lid or the paper plate from thickest to thinnest. Once you have the rubber bands in place, place a piece of duct tape on the lid or the bottom of the plate to keep the rubber bands on the lid. Afterwards, color one or both sides of the popsicle stick and tape one end of the stick in the same place as you taped earlier. After you're all finished making your instruments, get into groups of 3 or more and compose your own short songs to present in front of your peers. The first discussion question is, given what we've learned about how sound travels, why do you think each glass made a different sound? By hitting the glass, a vibration is created which is the same in identical empty glasses. As water is added to the glass, the vibration of the glass itself is dampened or slowed, and the pitch becomes slower and lower. In each glass, there's a different amount of liquid to travel through, so there's a different amount of sound remaining after a certain amount of time. This can affect how high or low the sound is and the volume so that each glass will produce a unique sound. Empty glasses will have faster vibrations, higher pitches, and will stop making sound more quickly. Glasses that are completely full will have slower vibrations, lower pitches, and the sound will last much longer due to the amount of particles to jump off of. The second discussion question is, how do you think each instrument produces a different sound? Every instrument is shaped differently so that the vibrations from playing the instrument can come out of the object in unique ways. In the case of instruments like guitars or violins, where there are strings to be played, the thickness and tightness of each string affects how it makes the sound and how the instrument is made in the first place. In string instruments like guitars, there's a large hollow space below the strings where the sound travels and echoes, which impacts the volume of the sound. In wind instruments like trumpets or clarinets, the sound is pressed through the instrument by blowing on it. The shape of the instrument affects how the air travels through the instrument, such as what the particles bump into, and how much space they have to travel. I hope you enjoyed this week's activities and learned something new about sound. See you next week. Bye!